Okay, this is the lecture video for MAC 1140 Pre-Calculus. We're in section 11.7 where we're going to be taking a look at solving inequalities and specifically headed towards solving systems of inequalities. Okay, in the first example, we see a linear inequality. We're trying to solve this by getting all x's on one side and all constants on the other side. You should be able to give your answer using a number line and also an interval notation. You're not required to graph the number line, but it helps to get the interval notation correct. So in solving this, just copy it down here. I'm going to bring this negative 2x to the other side. You have a choice of what you want to do with that. I'm going to bring all my x's to this side, thereby canceling those. And I have 24 on this side. I've brought all x's to this side, and I have 5x minus 2. One thing you want to remember when you're solving inequalities is that the only thing that makes this inequality symbol switch directions is when your very last step is to either multiply by a negative or divide by a negative in an attempt to remove a negative coefficient. So be careful with that. I'll remind you when and if it happens. Okay, we're going to continue here. I'm going to bring this negative 2 to the other side, which means I'm adding 2 to both sides. It would be gone on this side, leaving you with just 5x is less than 26. Okay, divided by 5, divided by 5, and my solution set, or my solution interval, rather, is all numbers less than 26 over 5. Okay, let's check that real quick. Moved the 2x's over here and got 5x. Moved the negative 2 over here and combined it with the 24 to give me 26. So it was 5x is less than 26. At no time did the direction of this inequality switch because I was not dividing by a negative on my last step or multiplying by a negative on my last step. So when you're going to graph this on a number line, it's just this is the end point. It is an open endpoint. In other words, that endpoint does not actually belong to the solution point. It just acts as the anchor point so that you can shade from there. Everything less than this does belong to the solution set. So this is your solution set. Everything that comes from negative infinity all the way up to but not including 26 over 5. If you want to put that in pure interval notation, that would look like this. Everything from negative infinity up to but not including 26 over 5. When you want to say that that endpoint is not included, you put a parenthesis around it. All infinity symbols have parentheses around them. Okay, always read your solutions from smallest to biggest. In other words, left to right on that number line. That's one of the rules for interval notation. Okay, so that completes example 1. Example 2, now we move to a equation, a linear equation, and we're being asked to graph. So a little review of that. This would be completely a review for you, solving a linear equation. You go much further than that even in the class previous to this. You get into solving second and third degree inequalities. So just starting off with something easy, first degree inequality and a first degree equation. So when you're solving a linear equation so that you can graph it, you want to isolate for y. So bringing that right over there and moving the 3x to the opposite side would make it negative 3x. So your equal sign is still there. The negative 3x has gone over to the right-hand side, and we have a 12 here. You're then going to divide off that coefficient of negative 2 And that would give you -3 divided by -2. Those negatives would cancel. This would serve as the slope, and specifically, this is the rise, whereas this is the run. Slope is made up of rise over run. 12 divided by -2 is -6. This is your y-intercept, and it is where the graph starts. So you started at the y-intercept, and then you use the rise over run to get the next point. You only need 2 points because that's enough to connect and get your line. So starting at -6, 1, 2, 3, 4, 5, 6. It's right there. Then you're going to rise 3, 1, 2, 3, hold, and run 2. Okay, and then you're just going to connect those in the best way you can. And there's your line. Okay, this is y is equal to, remember that anything, if you recall, any line with a positive slope is going to climb upward and to the right. This is also known as an increasing line because the y values are increasing as you travel on the line left to right. Let's see, what was the constant? -6. Okay, and when you graph these in My Math Hub, all you're going to do is click the graph that looks like this, a line, and then click on 2 points and it'll connect them. Okay, in example 3, here we come to the equation of a circle, also covered in the previous course as well as the course before that. So hopefully you're recognizing that at this time since it's been at, since they tossed this to you at so many levels. So whenever both variables are positive, both squared, both with the same coefficients, and then a value squared over here, that is the equation of a circle. So really simple. If you remember the format, this is the standard form of a circle graph. And you can even write this in that form. You can write it as x minus 0, where this would play the role of the h, squared, of course. X minus 0 squared is the same thing as x squared. You could write y squared like that, y minus 0. So this would play the role of the h, this would play the role of the k. H and k happen to be the center of the circle, and you could even write that number as r squared. So you can take what you've been given and write it in this format. That's why you're given the form of different graphs, so that you can fit it into that form and identify key points on the graph, namely the center and the radius. So that 25 you see there, if you want to write it as r squared, you can just write it as 5 squared. So this would be the r. Okay, so we're going to do a center right at the origin. Those would be our h and k values, and our radius is 5. So the way you graph a circle, don't bother graphing it on the graphing calculator. It's just way harder that way. All you have to do is go to your center point and then stretch out 5 units to the right, to the left, and up and down from that center point. So 1, 2, 3, 4, 5. Put a point there. Then go 5 the other way. 1, 2, 3, 4, 5. Then go 5 up, 1, 2, 3, 4, 5, and 5 down. And then just connect those outer points. And there's the graph. Okay, moving to example 4. When only one of the variables is squared while the other one is first degree, that would be a parabola. So whenever you have the x squared but the y is linear, that is either an up or downward parabola. When the y is squared but the x is first degree, then you're talking about a sideways parabola. And depending on what the coefficient of the squared term is, that's what tells you whether it opens left or right. Now we are specifically looking at vertical parabolas here, and that's what this example is about. When the square is on the x, it's either an upward or a downward parabola. Those are referred to as vertical parabolas, whereas these are horizontal parabolas, and they're not even functions. Okay, so in this particular problem, the a value, which you're always going to find in front of your squared term, is 1. And this is the k value. So you can even write this just like this. You can write it as, move this up a bit, as y is equal to 1. 1 will play the role of the a value. You can write your x squared as x minus 0. That's the same thing as just x squared. And then your k value would be that 4. So this is k, this is h, and because your a value is equal to 1, which is greater than 0, what that means, let me move this over just so it's not getting jammed into your h value. So that's your h value, and this value right here is your a value. The number 1 is greater than 0. Therefore, this parabola opens up. All good things to know so that you're not graphing a bunch of needless points and not even getting the shape. You need to have these shapes memorized at this point because this is, this is kind of like the third attempt to try and introduce these shapes to you. Intermediate, college, and then they get mentioned again in pre-calculus. Okay, so let's see. We can use our vertex, which is h and k. And in this example, that would be 0 and 4. 1, 2, 3, 4. So that's going to start right there. You can also think of this as a vertical shift. If this was just x squared without that there, it would start at the origin, but the whole vertex is lifted up. And then you have a leg to the right and a leg to the left. Now, this graph is symmetric to the y-axis. In other words, you're going to have mirror images on the right and left. So if you would just find a point that's over here to the right, you could mirror right off of the y-axis to get the other point so that you don't have to plug in again. So what I'm going to do is just move away from the y-axis. You can move 1 space away. You can move 2 spaces away. I'm going to move to 2 just to get like a nice fullness on that leg on the right-hand side. So I'm going to move 2 units to the right, which means I'm going to be at x equal to 2. So I am choosing a particular x value, which of course is a key characteristic of graphing by hand. Okay, so if I choose x equal to 2, that means I'm going to plug that value in for x. So just plug that right in for x. Okay, this is my equation that I'm plugging it into. So it's y is equal to, move this a little bit, y is equal to x squared plus 4. Okay, that would be 4 plus 4 or 8. As a point, it would be the number I chose to plug in for x, and the answer that I ended up getting is y. So I can plug in when I'm at, now right now I am at 4. So when I do 2, 8, I'm going to be 1, 2. This will be 2. I'll be at 4, 5, 6, 7, 8. So notice that this point, if I'm going to mirror, use this as the mirror and do a mirror image over here, I'm 2 spaces to the right, and from that vertex, I am 4 spaces higher than I was at the vertex. 2 over 4 up. Do the same thing on the left side. 2 to the left, 4 up. And then you have a nice symmetrical parabola. Okay, that's example 4. Okay, moving to example 5, where we talk about parallel versus perpendicular lines, just reviewing those concepts. So just wanted to remind you that when 2 lines are parallel, that means that their slopes are equal. When two lines are perpendicular, on the other hand, their slopes are opposite signed reciprocals. Okay, so in this particular problem, it says the two lines 2x plus y equal to 6 and 4x plus 8y is equal to 0 are parallel. Is this true or false? Well, you have to identify what the slope is. Solving for y will allow you to identify the slope. Solve for y to identify the slope. When you solve for y, you are putting it in slope-intercept form. And putting it in slope-intercept form like this allows you to identify the slope. The slope will just be the coefficient of x right there. Okay, so I'm going to take this equation right here, solve for y by just pulling the 2x over to the side where the 6 is. So it's going to be y is equal to negative 2x plus 6. Okay, in that one step, I have isolated the y. Therefore, this equation is in slope-intercept form, and there is my slope. So for this first line, I'll just call it slope number 1. My slope was negative 2. Okay, then we have this other line that's 4x plus 8y equal to 0. So again, you want to get it in this form to reveal the slope, slope-intercept form. So I'm going to try and isolate the y just like slope-intercept form does by bringing first the 4x over here. That would give me 8y is equal to negative 4x plus the 0 that was there, so I could just write it as negative 4x, and then I can divide by 8, and I would end up having y is equal to negative 1/2 x. And this would be for my other line. I'll just call it y sub 2. Or I can specify that this is the slope for the second line, negative 1/2. So I had this slope for my first line and this slope for my second line. So when they try to say in this particular example that they were parallel, that would be false. Okay? They have to be equal slopes, just as it says right here, in order to be parallel. These, in fact, are neither, because if they were perpendicular, this would be the opposite signed reciprocal. It's a reciprocal, but it's not the opposite sign. So answering this particular question, it's just false. Okay, example 6. In example 6, you start graphing. You are missing one of the variables. You don't have a y variable. So when you're missing one of the variables, you're either talking about a vertical or a horizontal line. Okay, so when you're going to start graphing these inequalities, I suggest that you write it as an equation. In the case where you're missing a variable, you don't have to worry about getting it in a particular form. You can just design a couple of points for yourself. This is called a consonant equation, and any point that you design is going to have an x-coordinate of 3. Since the y-coordinate is not present, that means y can be anything for the variable that's missing. So when you design your own points, you could select 0 if you want. You could select a negative. It just doesn't matter as long as you allow x to be 3 each and every time. Okay, two points is enough to plot. And as you can see, when you go to plot these points, when the y value is missing and only x is there, you're going to get a vertical line. But you'll see that if you don't already. So 3, 0 is 1, 2, 3, put a point right there, and 3, negative 1 is right here. All you have to do is connect those points, and you will see that you have a vertical line right through x equal to 3. Every single point on this line has an x coordinate of 3. Okay, moving on to 7. 7 is also missing a variable. Oh, I forgot to shade. Okay, so you start off by graphing the boundary line. I do want to mention that because of the equal sign in this particular inequality symbol, that equal sign means that rather than making your boundary line out of dashes, it means that it's a solid boundary line. Okay, so try to be aware of that when you draw your boundary line. Then as far as shading, when you have in the case of a vertical line, I mean, I would say, when I talk about shading, I would say shade either above or below, but that kind of doesn't make sense when the boundary line is vertical. So instead of above and below, we'll say right and left. So when you're talking about values that are less than this boundary line, less than would be to the left, if that's what's in your particular inequality, and if it was greater than or equal, you would shade to the right. Okay, we are shading this x. You can put that symbol back in now. X greater than or equal to 3. So all values greater than or equal to this boundary line are over here. So the shading would be over there. Okay, moving to example 7. This time we're going to first get the boundary line for negative 2y is equal to 10. I'm going to divide by negative 2 here, divide by negative 2 here, and I get y is equal to negative 5. Once again, you're missing a variable here. So the easiest, quickest way to get the graph, rather than, slope and rise and run and all of that, what you want to do is just design a couple of points. Make sure that the y value is always negative 5, and for the variable that's missing, x can be anything. Sorry, dog's gone wild. They're the ones running around like crazy in the video. Okay, so I'm going to let my y be negative 5. And x's can be whatever you want. You can just choose whatever you want for x. Okay, when you go plot these points, you'll see that you have a horizontal line. Okay, so 1, negative 5. Negative 5 is right here. So 1, negative 5 is right there. And then 2, negative 5 is right there. And it would just be a bunch of points that line up at a depth of negative 5. So you can draw that line right through negative 5. Okay, as far as the shading goes, you can talk about above and below the boundary line. Once again, my boundary line was solid, and that is because of this little piece of an equal sign, just like the previous problem had a piece of an equal sign. If we get to the point where we have an inequality that doesn't have that, then we'll just make it out of dashed lines, meaning that it's just not solid. And there is a difference between the two. And I will write that as soon as I get done graphing this. When you have a solid boundary line, that means any point on the boundary line is actually a solution. Whereas when the boundary line is dashed, that means none of the points on the boundary line are actually solutions. So here the boundary line is solid. Okay, and because we're going to bring the inequality symbol back into the problem now, so we had y is equal to -5. Put that boundary symbol right back in there. Now I want you to think about this. With respect to graphing an inequality, you had this, and what happens when your very last step is division by a negative? And if you want to just go back over the steps, you're dividing by -2, and if you recall, because this is going to make a difference in the shading, when you divide by a negative on your very last step, that's going to take this and it's going to switch the direction. So this is going to become, instead of greater than or equal, now it doesn't change the boundary line, but it changes what side of the boundary line you shade on. This is going to become less than or equal to -5. So we already have the line y equal to -5. Less than means shade below. And if it was greater than, you would shade above. Okay, so anything down here is considered a solution. So if somebody was to say to you, is 2, -10 a solution? Yes, as long as the point lies in the shaded area or on a solid boundary line, it is considered a solution. In this particular problem, let's say somebody said, is -1, 2 a solution? No, it is not, because it doesn't lie in the shaded area, nor does it lie on the boundary line. So you should understand how to read your graph. Okay, so possibly you want to put this for solid boundary lines. Any point on the boundary line is considered a solution. Whereas for a dashed, I'll put that down here, for a dashed, now you don't have a dashed boundary line in either one of these, but I just want to put the information here for problems that may come up. For a dashed boundary line, none of the points on the boundary line are solutions. Okay, so both examples 6 and 7 had solid boundary lines. Okay, moving to example 8. Okay, we're moving our way towards systems of inequalities, and in that case, what's going to happen is you have to be well versed at just getting the graph of a linear inequality. We'll move to inequalities that are not, not linear, or they could be part linear and part not linear, depending on what I give you. But when we move to the systems, you're looking for where the shading overlaps. Right now, we just continue to refine our graphing skills. So in example 8, again, we have both x and y in the problem, and you're going to solve this. And if you don't want to write it with the equal sign to begin with, you can just go right to the solution for the inequality and understand that you're graphing this as though it were a linear equation. So you could leave the 2y here, pull the 3x to the other side. In other words, subtract 3x from this side, which would make it go away, and then it appears on the other side, but with the opposite sign. So at that point, you have not made this switch, because just subtracting 3x and subtracting 3x does not cause that to happen. I'm going to write the negative 3x first, followed by the positive 12. Continue to solve. Now this step is going to cause this symbol to switch. Okay, it's division by negative on the last step, or multiplication by a negative in the case where you're trying to remove a negative fraction. Either of those things, division or multiplication by a negative, cause this symbol to switch. So it switches to this. This becomes just y. This becomes negative 3 divided by negative 2, or 3/2 x. 12 divided by negative 2 is negative 6. So you would be starting here. This is your y-intercept. So 1, 2, 3, 4, 5, 6. And then you would build to get another point using the slope. Specifically, the top is the rise and the bottom is the run. So you go up 1, 2, 3, run 2. Then plot the point after you've done both the rise and the run. Now this particular inequality symbol does not have an equal sign. So when you connect these 2 points, you want to make a dashed boundary line so that it is clear that nothing on this boundary line is a solution. Okay, so if someone was to say, is this a solution, this point at 0, negative 6, is this a solution to this inequality? No, it is not. Nothing on the boundary line is a solution. And you can plug in 0 for x and negative 6 for y, and you would see that it's not a solution. See, let's check it out. Check out points on the boundary line. Like this is a number on the boundary line, like 0, negative 6. And you'll see that these points, nothing on this boundary line is a solution. So you would go negative 2 times y, there's my y value, plus 3 times x, plus 3 times x, and the x was 0. And supposedly, if that really was a solution, then you would come out with a true statement right now. So this would be 12 plus nothing, which is just 12. And that is not a true statement. 12 is not greater than itself. So this is false, this statement. And any time you pick a point on a dashed boundary line, you're going to run into a false statement like that. Whereas if you plug in the points on a solid boundary line, they will work. Okay, so let's get that shading to happen. Because you have a less than symbol, that is going to be shade below the boundary line. If it was greater than, you'd be shading above the boundary line. So anything down here is a solution. So if somebody was to say, is 10, negative 5 a solution? Yes, because it would fall right in this shaded region. Okay, moving on to inequalities that are not linear. In example 9, you have a circle. Okay, if this was an equation, it would just be the equation of a circle. Okay, again, when you have both x and y in their squared form, both are positive and both have the same coefficient, it's a circle. And then you have a number over here. Now, this is a decimal, so we're just going to have to approximate what the, what the radius is. And I think what I wanted this to be, because I wanted this to come out nice, I wanted this to be 16 and made a typo. I'll have to fix the outline, which I will, before I post it in your Blackboard shell. So change this to 16 because I don't think we need to be getting into decimals when we're just trying to figure out how to shade right now. Okay, so let's treat this as though it was x squared plus y squared equal to 16, just to get the boundary line. The center, I went over how to graph this on the previous page. The center would be 0, 0. And the radius would be, this is the radius squared right here. And then the center, because there's nothing being subtracted or added here, the center is just 0, 0. And the radius would be square root of this. Okay, so you're going to go right here, and then you're just going to stretch it out. 1, 2, 3, 4. Put a point there, and then 1, 2, 3, 4, going the other way, and 4 going up, and 4 going down. Okay, then let's see. This is a equal sign under here, so that boundary line for the circle is solid. Okay, now let's consider what the original inequality said. Do you see that it has a less than symbol? That means you are going to shade the inside of the circle. Those would be all the values less than the boundary line. If it had a greater than, okay, and I'll put that here. If it's less than inside an equation, a circle inequality like this, then you're going to shade the inside. And if it was a greater than symbol, then you would shade the outside. Look like a little sun. Okay. So in this particular problem, we're shading all of the inside, anything in here. Now, when you are graphing these in MyMathLab, you're going to graph the boundary line with either a dashed or solid line. You'll click on the tool that has this shape of a line, and you can tell it whether you want it to be dashed or solid. And then there's a little thing that looks like a bucket full of paint. So when you have settled on the area that you want to be shaded, you click on the bucket that looks like it is tipping over and spilling some paint, and you click it in the area where you want it to shade, and it'll shade that entire area. So here, if you were going to graph this in MyMathLab, you would click the little graphing tool that looks like a circle, and then you would provide it with a couple of points, maybe the center and then one other point. And then you would take the bucket symbol that looks like it's tipping over and click inside the circle, and it would shade inside of it. Okay, for example 10, now we get into systems of inequalities. And we are going to graph two graphs this time and look for where the shading overlaps, because only that would be where where you're going to take that spilled bucket of paint and click in the area where the shading overlaps. Okay, you don't use the bucket twice. Just wait to see where it overlaps, and then when you go to give your answer in MyMathLab, you'll do each of the boundary lines, and then you click on the bucket symbol, and then click on the graph where the shading overlaps when you did it by hand. Okay, and if the shading does not overlap at all, then you're going to say no solution, because when you're graphing a system of inequalities, only the overlap is considered the solution. Only where the shading overlaps. And this is for any system of inequalities. Okay. All right, so let's go and graph this first inequality. I'm going to bring this x over here, and it would become negative x once it jumps to this side, and I'll scoot that positive 2 over. This is your y-intercept, so you're going to start your graph here because this is a linear equation, so the method is to start at the y-intercept and then use this right here, the -1, as a fraction, where this will play the role of the rise and this will play the role of the 1. that boundary line is going to be solid. Okay, so then you're going to come here and you're going to go to 2, plot a point, and then you're going to rise down 1, run 1. And then just those 2 points will allow you to get this line. Okay, solid boundary line. Then go look at the inequality symbol. This is a less than inequality symbol, so you're going to shade below the boundary line. Okay. Then next thing you're going to do is graph the other shape. The other shape comes from this 4x plus y is greater than 8. Solve for y again. So it's y. I'm going to bring this 4x over here, at which point it'll be negative 4x. That is a greater than or equal to symbol, so I'm going to have a negative 4x on the right-hand side as well as a positive 8. This is my y-intercept where the graph starts. And this is my slope, where this is the rise and this is the run. Okay, so I'm going to be at 2, 3, 4, 5, 6, 7, 8. So that'll be right there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, then I'm going to do a rise of negative 4. That means I'm coming down. When you rise up, it's because it's positive, and if the rise is negative, you go down. So 1, go down 1, 2, 3, 4. And don't plot the point yet because you still have to do the run and do the run. And there's my other point. Okay, so now I'm going to connect these 2 points. And I'm going to shade above. Okay, so again, you're going to have a solid boundary line, just like you had one here. Here I shaded below. Here I'm going to shade above. You're shading below because of that less than symbol. Here I'm going to shade above because of the greater than symbol. Okay, so let's see if I can connect these. That's the best I can do without a ruler, and I'm going to be shading above. Okay, let me try to extend this so that you can see nicely where the overlap is. Okay, I'm shading for this second one that I graphed, I'm shading above. So that would be right here. And hopefully you see where it overlaps, but it's right in there. So if you're going to do this in my math lab, you're going to create this boundary line. Don't shade though. Then you're going to create the other boundary line. Don't shade that. On the paper where you've worked it out yourself, identify where the overlap is. Then go into your My Math Lab and put the bucket with the the tipped over bucket right in there and click. And it'll shade just the overlap part. Okay, and example number 11. You have another system. We're going to be solving this. So here I'm going to bring the 2x to the other side. And that would be negative y is less than or equal to negative 2x plus 10. I'm just scooting that 10 over to make room for the negative 2x. I like to write my x term first. Then I'm going to be dividing by negative 1 on my last step. And that sort of operation is going to make this switch. So it's y instead of less than or equal to, greater than or equal to. Negative 2 divided by negative 1 is positive 2. 10 divided by negative 1 is negative 10. Okay, and then you can go and graph it. It is going to be a solid boundary line, and you will be shading above to kind of get at where the overlap is. Okay, this is the y-intercept where it starts, and this is your slope. That's your rise and your run. Okay, so -10, we don't even have 10 spaces. It's 1, 2, I think there's only 8 here. 3, 4, 5, 6, 7, 8, 9, 10. Just extend it. Oopsie. See if I can make it a little straighter. I'm just kind of approximating here. All right, so we're going to start at -10, and then we're rising up 2 to 8 and running over 1. Okay, I'm connecting these with a solid line, and I am going to be shading above. Okay, then I'm going to go and graph the other one by solving for y first. So I'm going to leave that -3y right where it is, bring the 6x to the other side, and it will be -6x. Then I'm going to divide off the -3, divide off the -3, and because I am dividing by a negative here, it's going to cause this to switch. So this is going to end up being y is less than or equal to -2 or +2x, because those negatives cancel. Okay, so let's check all this out. This would be -y is less than -2x plus 10. I divided by -1 and got +2x minus 10. I plotted at -10, and then I rose up 2 and ran 1. So that was my solid boundary line shaded above. This one, I moved the 6x over to the other side in an attempt to solve for y. I divided both sides by -3. That caused this to switch to a less than symbol. And I'm going to graph this now. So, there's no number here. So that's the same thing as saying that you have a y-intercept of 0. And then you're going to go up 2 to right there. Don't plot your point though, just go up 2, and then don't forget to do your run. So this is your rise, this is your run. You're always making 2 moves before you plot the next point. So up, rise 2, run 1. Looks like right about there. Okay, and then I'm going to connect these also with a solid line. And then I'm going to be shading below because of the less than symbol. Okay, so let's see. So this is my boundary line right here. I'm trying to shade below this. And so if I'm shading below this line, it would be like this, and then where the shading overlaps is right in there. Once again, you would go into my MATLAB, graph each of these lines by just clicking the line symbol and then indicating 2 points that are on the line. Then you would go and graph the other line the same way. Then you would touch the little bucket symbol that looks like it's spilling paint, but right inside here where you have already discovered by hand that the overlapping is. And that's what you would allow MyMathLab to shade. Okay, moving to number 12, graph the given system of linear inequalities. Okay, let's see what happens here. So I'm going to isolate the y. So leave that -y there, but pull the 3x to the other side. There's a greater than or equal than symbol. The 3x would appear over on the right-hand side once it moves from the left to the right. This is the same thing as subtracting 3x on both sides, and that's why it appears as a -3x on the other side. This +3, I'm just scooting it over. Now I'm going to divide by -1 on both sides. That leaves me with y is less than or equal to, because this switches. Okay, then this is going to be positive 3x minus 3. Start here, and then build your next point with rise over y. So I'm going to go to 1, 2, 3. I'm going to start right there. Then I'm going to rise 3, 1, 2, 3, and I'm going to run 1. Okay, this boundary line is solid. And I'm going to be shading below. Okay, so this is a solid boundary line, shade below. Okay, so that's going to be right there. Okay, remember we're looking for the overlap of this system. I'm going to also solve for this inequality, leaving the negative y where it is and pulling the 3x to the other side. That's a greater than or equal to sign presently. The 3x appears as a negative 3x. When we bring it to the right, scoot the negative 6 over. Then divide off that negative 1 coefficient. That's going to cause this symbol to switch directions. And this will become positive 3x plus 6. Okay? All right, now you can graph. We're going to be starting here and using 3 over 1 as the rise and run. So we're going to start at 6. 1, 2, 3, 4, 5, 5, 6. Starting right there. And then we have to rise 3. 1, 2, 3. Let's just say that's 3 and over 1. So right there, again, you have a solid line because of the equal sign, and this time we're going to shade below because of the less than symbol. Okay, so you go like this. And then it turns out that there's no overlap here, but there is overlap right in here. Okay, so that's where you would put the little bucket so that you're telling it where the overlap is. Okay, example 13, graph the given system of inequalities. Okay, let's see what happens with this. We're going to pull the 2x over here. You get y is less than or equal to this 2x becomes negative 2x when it jumps to the other side, and there's a negative 4 over there. Okay, there is no switching the direction, so we're going to be graphing this starting at negative 4 and then using a rise of negative 2 and a run of 1. So if I rise negative 2, that means go down 2, run 1. Okay, so those are my 2 points. This is a solid boundary line. Okay, so this one is solid. And I am going to shade below the boundary line because it's a less than symbol. So it's going to be all of this in here. All right, then the next one is trying to isolate for y. So we're going to have y. This 2x will come to the other side of this greater than or equal than symbol, appearing as a negative 2x. That positive 2 was already there, and so this is solved. So now you are going to start here at 2, and then use the negative 2 over 1 as your rise and run. Okay, so let's start at positive 2 this time. And then I'm going to go down 2 over 1. Okay, notice that both of these had the same slope. That means they are perfectly parallel. I mean, mine is not going to work perfectly parallel probably, but I'll do the best I can. have like a gigantic point like that. Okay, so this first one I shaded below, that was all of that. And then now I'm doing this one where I also have a solid line, but I am shading above because of the greater than symbol. So all of this goes together. Okay, so this time I'm shading above. Notice that in this particular case, there is no overlap. So these problems seem very similar, but in fact, you have three different scenarios here. Here, the overlap was in between the lines. Here, the overlap was completely to the right of one of the lines. Only that region served as the overlap. So this actually did have a solution. This had a solution because there was overlap in both of these. This has no overlap, so that we say there is no solution since there is no overlapping shaded area. Okay, moving on to number 14. Okay, number 14, we start to mix linear equations with the type of graphs that have curves on them. And we have gone over already in this section the parabola and the circle. And you're going to see that happening in numbers 14 and 15. So I think I'm going to graph the easy one first. This is I can already graph this. The y is already isolated, which is the way it needs to be when you're graphing a line. This is where you start, whatever the constant is, you're going to start there. So I'm starting at -1, and then the, let me write this a little bit bigger so you can see it. So that's where you start, and then the coefficient of x is just 1. You can think of that as 1/1, so the rise is 1 and the run is 1. So rise 1, run 1. We're going to connect this particular line with a solid line because it does have an equal sign underneath it. So here's this line. Then because it's a less than symbol, we're going to shade below the boundary line. Okay, then as far as the other one goes, you can treat it as though you're graphing this. And I was just talking about this a minute ago. This is a parabola, and that parabola, you can write it like this if you want to, or you can just plug in points. It is x minus 0 squared minus 9. When you write it in this standard form, what you're figuring out is the vertex. So the vertex is 0, what comes after the minus sign, and the -9. This is considered h and k, and they spell out the vertex. So 0, 9. This is -8 right here, so go down one more. And right there is where it starts. And then since this is a positive x squared, when the square is on the x, that means that it is a vertical parabola, meaning it opens up or down. But since this value is 1, this is your a value, that a value is positive, and therefore it has to open up. So it's a good thing to keep in mind. When you're graphing. So what you can do is just look for one point to the right or to the left and then mirror off that point. I'm going to pick a point that's 2 spaces away. I like to move away from the vertex a little bit. So I'm going to move 2 spaces away, which means I'm choosing to use x equal to 2. And you're allowed to choose whatever you want for any function as long as it's within the domain, and then that means you're going to plug it in. So if I plug this in, right here it would be 2 squared minus 9, which is 4 minus 9, which is negative 5. Okay, so I put the 2 in there, subtracted 9, got a negative 5. This 1, 2, 3, 4, 5. Okay, and then you can mirror right off that point. That point is 2 spaces to the right. And if we were at negative 5 and now we're at negative 9, 1, 2, 3, 4, 5, just make it at the same height and 2 spaces this way. You can go 2 spaces, match that height. So it's just 2 points on either side of the y-axis. Connect through the point and shade. Okay, let's look at what kind of inequality symbol we have here. When we're doing this, it's y is greater than, and I actually should have made a dashed boundary line. So what I'm going to do is just make this look dashed. Try to do a little cleaning up here. Okay, so nothing on this boundary line. Okay. All right, and this is a greater than symbol. When we go to shade this, we're going to be shading above. So I'm going to write that right here. In the case of the parabola, which is this x squared minus 9, we're going to shade above the boundary line. So that would be all of this. Because below it would be underneath here. And then you just have to try and see where the overlap is. So we went down from this boundary line and we went up from this boundary line. So the overlap is right in there. Okay, so in this case, you would go into My Math Lab, click the graphing tool that looks like a line, tell it what 2 points are on the line, end. Then go click another graphing tool, the one that looks like the parabola. You can tell it whether you want dashed or solid lines. And you would click the vertex, and probably one other point should be enough. Don't use the painting tool until you already have figured out on paper what the overlap is. That's right in here. So you get right in there and click on that in this area right here, and it will shade that. Okay, example 15, graph the system of inequalities. So once again, we have a circle. Here the center is 0, 0. This is the r squared value. So r is equal to 6. And this is at, the center is at 0, 0. So right here, 1, this would be 1, 2, 3, 4, 5, 6. So right there. 1, 2, 3, 4, 5, 6 right there. And go 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Let's see. This is a solid boundary line on that circle. We are shading less than the boundary line, which means we're in here. Okay, then let's see, we have to also graph a parabola. And so for this parabola, the vertex would be, again, this can be written as x minus 0. That's the same thing as x with a square minus 6. This plays the role of the h, this plays the role of the k. So your vertex on that parabola is 0, the number that comes after this minus sign, and negative 6. That's where you're going to start your graph. Okay, again, because the squared term has a positive coefficient, that means that it's going to open up. This boundary line is also going to be solid. So you're going to go to 0, negative 6, 1, 2, 3, 4, 5, 6, which is right there. You're going to start it there, and then you're going to build a leg on this side and then mirror off that point across the y-axis. Okay, so let's see. I'm going to go to 2. I'm going to go 2 spaces away. That means I am choosing to use an x value equal to 2, and I'm going to plug it right into this. So my y value would be 2 squared minus 6. Which is 4 minus 6, which is negative 2. Okay, so the point I'm going to plot is 2, negative 2. So 2, 1, 2. And then to mirror off that point, this is 2 spaces to the right and 2 spaces up. Oops, I put this in the wrong spot. I was supposed to plot 2, negative 2. So let me go 2 and then down, negative 2. Okay, so it's 2 spaces to the right, and it is up at this height. So I can do the same thing over here. I can go 2 spaces to the left and then match that height. This boundary line is also solid, and I'm going to shade greater than the boundary line. So shade above the boundary line. Okay, so everything inside the circle is shaded, and then all of this is shaded. This is all considered the above part. Where is the overlap? Well, none of it out here is, so that would just be this area right in here. You have shading for the circle, and you also have shading for the parabola there. Okay, for this last problem, you already have 2 lines that are presented here, and we're going to try and come up with a system of linear inequalities that corresponds to the given graph. Okay, so let's see for this red line. Okay, on the red line, there are 2 points, 2020 and 1515. It's a straight line, so I'm going to write the equation of the line. Then I'm going to turn it into an inequality. Okay, so it's y. And you can do, let me see, let's do the slope first. Why don't we do the slope first instead of jumping into what I'm doing. This is the formula for the slope. Okay, so on the red line, one of the y's is 20, the other one is 15. Move in that same direction when you do the x's. Grab the numbers from here first. And then for the x's, same thing, 20 and 15. So this is going to be 5 on the top, 5 on the bottom. The slope is 1. Okay, then as soon as you have that slope, we can do the equation of the line this way, and then we'll turn it into an inequality. I'm going to use the equation of the line, and I'm going to use the point slope formula, which is y minus y1 is equal to slope times x minus x1, and then we can get it in slope-intercept form. So I'll use this point right here, subtracting 20, using my slope, then subtracting the x value that goes with it. You can either use this point or this point. In the end, it's going to come out the same either way. It doesn't matter whether you use the 20-20 on the red line or the 15-15. Once you get it in slope-intercept form, it's going to come out the same. Okay, so this would be y minus 20 is equal to x minus 20. So if I was going to solve for y to get this in slope-intercept form, I would bring this over here, and it would be y is equal to, this would be gone because now it's over here appearing as a positive 20. These two combined would be 0. So this is the equation of the red line. Okay, as an inequality, it would be like this. Let's see where the shading is. The shading, if this is where the overlap is right here. Oh wait, it looks like there's 3 of them here. So I just did this one. Let's call this red line 1. There's 3 different lines here, so this is going to be a pain in the neck. Okay, so if the shading is over here for red line 1, if the overlap is over here, then it would have had to have been shaded above because it's over here. It can't possibly be over there, or it wouldn't have been the overlap. So it would have to be above. Y is greater than, rather than the equal sign, y is greater than x. So that's one of the inequalities in the system. Okay, then let's do the other one. This will be called red line 2. For this one, it's just easy because it's a vertical line, and all vertical lines are just x is equal to. So we don't have to do a bunch of work like we did for this one. X is equal to, and then the x value that it runs through. And you can see that everything on this red line 2 runs right through the x value 20. See how this is a point on that red line, and it's got x value 20, and so does this one. So x is equal to 20. Now, for it to have an overlap on this side, it would have had to have been everything less than this line. So as an inequality, the line would have been x is less than 20. Okay, then for that green line, that, because it has a slant on it, we're going to have to do some work for it. So the first thing I'm going to do is the slope. I already put the formula up there. I'm going to take 2 points that are on this line, and I'm going to do the y's at the top because it's y2 minus y1. I'm going to use 70 and 50. And then the corresponding x's are 0 and 20, which gives me 20 on the top and 20 on the bottom, but the 20 on the bottom is negative. So that slope is -1. And this is for the green line. Okay, then I'm going to try and get the equation of the line, and it's going to be y minus y1. I think the point that I'm going to use, just like the point that I used here for y1 and x1, was 20-20. Although you could have used 15-15. This played the role of x1, this played the role of y1 when I plugged in here and here. Same thing here. I'm going to use for this green line. I'm allowed to use anything that's on the line. I'm going to use the 0.70. Okay, this will be the x1, this will be the y1. So when I go y minus y1, it'll be y minus 70, and then it's going to be slope. I'm following this formula once again. Let me highlight that so you can concentrate on. This is what you use for a slanted line. So it's y minus y1 is equal to the slope. The slope this time is negative x, and then it would be x minus the x coordinate that you're using here. So that would end up giving me y minus 70 is equal to negative x. And if I was going to get this in slope-intercept form, that means I'd be isolating the y. So it would be negative x plus 70. Okay, if I was going to write that finally as an inequality, I don't know if I can fit it over here, so I'll write it over here. So it would be y over here, the negative x plus 70 over here, and we got to figure out based on the shading whether I should put a less than or a greater than symbol. Here is the green line. For the shading to overlap over here, it would have had to have been shading below. All of these have solid boundary lines, so everything I am writing as an inequality should have a little piece of an equal sign. So let's put one there. Let's also put one there. Okay, so these are the things that are going to go into my system. This and this. So, final answer. Y is greater than or equal to x. X is less than or equal to 20. And y is less than or equal to negative x plus 70. That concludes section 11.7.